Hello, good morning. How's everyone doing? Welcome to day 3. I had very simple goals. Make sure I don't trip on the stage there. So I think we're up to a good start here. All right. So what we're going to do today is talk about how Cisco is helping redefining universal zero trust network access. So before we jump into the topic today, and firstly, thank you for your interest in this topic and coming to the session here. I realize you have a ton of things you can see here, so thank you for taking the time to come to the session here. I think one thing we can all kind of universally agree on is the fact that zero trust is needed everywhere, right? I think as a topic or as a broad area, zero trust is not necessarily new, and it is a fundamental requirement if you think about how we want to be able to secure hybrid work. But if you talk to a lot of customers, and when we talk to customers, they always say that, hey, a lot of our projects are either incomplete or they're stalled for whatever reason, right? One of the big areas that we often find is that, when you think about point product solutions in the space, it is very, very narrowly focused on one thing, which is, hey, you have a user who's on a managed device, and they're accessing a application for that purpose, right? This is where I would argue that, this is how we're actually redefining universal zero trust network access to make it applicable to every user, meaning if the user is a remote user, if it is a managed user, unmanaged user, doesn't matter. If the user is at home, in their home office, if they are remote, if they are in their branch office, doesn't matter. We can seamlessly sort of extend this security construct across all these different locations. Now, what does it mean to be universal, right? That's the fundamental thing I want you to sort of think about and take away, that regardless of where that user sort of resides, we want to be able to enforce a consistent security policy and a consistent experience regardless of where they sort of are originating from. Now, if you haven't seen sort of what we have done in the space for a bit, I want to just take maybe one step back and sort of introduce you to some key concepts, key pillars, right? The first one is that of how do we help teams modernize application access and ensuring that there is actually least privilege consistently across these elements. Now, you can think about this broadly in the sense of, hey, you want to be able to secure internet access and then private access. Those are kind of the broad themes that we want to be able to secure. The second piece is being able to extend this concept of identity, or taking this identity context and extending it beyond the elements where we sort of learned it, right? What I mean by that is like, hey, if you have a user or an IoT device, how do we enforce identity consistently and also update the security policy as the risk changes? So that's the other aspect. The last piece is about how we want to be able to enforce building some operational resilience. Because we now have a distributed environment where we are sort of looking at how do we enforce, one, end-to-end visibility, and then second, how do we enforce the fact that, hey, when an operator goes and pushes a policy, that it is making the right change. So those are the kind of pillars we want you to sort of think about. And all of these can be delivered with our zero trust network access solution that we're offering. Now, there are some key announcements that we have made this week, and I want you to walk through this a little bit. So the first one is that of the hybrid private access. What this allows us to do is enforce a single policy with distributed enforcement in both the cloud and the edge firewall. I will go into a little more detail on what this sort of offers in the next couple of minutes, but just want to give you a little highlight here. The second one is the enterprise browser integration that we have with the Chrome enterprise browser. And what this allows us to do is actually extend the security not just for managed devices, but also unmanaged devices. The big use case that we see with the enterprise browser integration here is specifically extending this to unmanaged users and also some things like VDI replacement. The third one is super exciting, which is guardrails for AI use. You saw the keynote yesterday and all the advancements that we're making with our solutions for AI, but this is specifically targeted to look for things like prompt injections, how to harm prompts, and toxic content. So it's looking for those kind of things, right? And then the last one is policy assurance. What this allows us to do is quickly detect and figure out, hey, if I'm going to push a new policy, what is the net effect of that policy? Am I going to inadvertently actually take some people off the network and things like that, right? All right, so let's jump into these 3 pillars and some of these key announcements, right? It all starts with the Cisco Unified Secure Client for us. Now, what we did is we took our traditional VPN client, and then we fused it with a modern ZTNA client. And what this allows us to do is that it allows us to extend just beyond this remote access capability now. Now, we have a modular client, so what it allows us to do is get you going with VPN, and then you could go to ZTNA, and then you can also extend this to things like device monitoring, for example, digital experience monitoring, network endpoint visibility, endpoint security, and so on and so forth. So it allows us to keep going beyond just the traditional VPN client or the ZTNA client. Now, when we take that and then we combine this with the modern POP architecture that we've built, it becomes really, really powerful. So let me talk about why is this POP architecture so unique. There are four main things that I want you to sort of take away from this. So number one, we've built a cloud-native architecture for our POP network. What this allows us to do is portability, which we can take from our own data centers, which we can run in public cloud. We can run it in multiple environments because it is giving us a cloud-agnostic model. The second aspect is that we've actually built this on the backs of modern low-latency protocols and a high-speed pipeline that we use. So the low-latency protocol that we're leveraging here is called Mask and Quick. I'll talk about what this is in a second, but I want to focus on the high-speed pipeline that we leverage for this. Now, if you're not familiar with vector packet processing, this is a technology that Cisco has developed over the years, and it's an open source project that we leverage. Now, what this allows us to do is scale beyond the limits that typical SSE solutions sort of run into, right? Now, we couple this with something called Mask and Quick. Now, if I'm a big analogy person, so if you're not familiar with Mask and Quick, I want you to think about a new high-speed rail system, right? If you have a new high-speed rail system and you want to deploy, say, new tracks and a new train system on top of it, think of Quick as the track system that we're going to leverage, right? So what it does is that Quick is built on UDP, and this inherently allows us and gives us a few benefits out of the gate. One, with things like connection migration. So if you think about a traditional TCP-based connection or a TLS connection, it has to go through all the handshakes and things like that. But UDP is able to sort of seamlessly migrate connections in, say, lossy networks, right? So in that kind of scenario, it comes very, very handy. It also offers things like built-in encryption and so on and so forth. Now with Mask is the actual train that is going to carry all the ports and protocols. Now we couple all of these things with a relay-based architecture. The best thing about, and the most interesting thing about a relay-based architecture is the fact that both the user and the application are both going to be always isolated. So meaning, if you're on a device and you were to do some sort of discovery of, hey, what are the applications that I can access, you're actually just going to see your local loopback address. You're not actually going to be able to do any sort of application discovery. The only way a user is going to be able to connect to an application is through this identity-aware proxy that sort of sits in the middle. Now, we take this concept and this POP architecture further by providing something called hybrid private access that we're launching here. And what this allows us to do is actually take that same experience that we have for a user today connecting from a remote site and extending this into the office and into the data center. And the other use case that we see here is that for sensitive applications. So if you have sensitive applications that should not be going through the cloud enforcement, now we can enforce that locally in the data center itself. We can take these same architecture and then also provide it for resilience purposes for failover with the on-premises firewall. I want to make this a little bit real for you and for you to be able to sort of visualize this, right? Now, let's assume we have a roaming user. And the normal sort of course of operation is always going to be, hey, the roaming user is going to hit the secure access proxy that lives in the cloud, and they get access to the backend resources that may live in the data center. But let's take now an example of a user who is actually in the office. And we don't want this user to go to the cloud and get the cloud hairpin. We can use that on-premises Cisco firewall to do that enforcement for us. The second use case that I talked about, where we want to be able to provide access to private applications without going to the cloud, that's the second use case that we can solve for here. And then the third use case of resilience. So in the event that we have an outage in the public cloud for whatever reason, we still can enforce locally on that firewall as an example. Now, for those of you who are wondering, like, hey, how does all this sort of come together? Do I need to manage this separately? Do I need to manage policies and so on and so forth? And if you have noticed, there's a policy button in the middle. And that's where security cloud control sort of comes into place. So what this allows us to do, and all the components that I just talked about, right? So when you think about secure private access, secure internet access, and so on and so forth, all of these can be delivered through our single secure access UI. Single console, single UI that can deliver all of these capabilities. So the days of going through 7 consoles, 6 consoles, whatever, to do all of these things are kind of gone. But we're further abstracting this and further unifying this policy administration for things like firewalls, secure workload, and other capabilities, and using capabilities from security cloud control to deliver this kind of unified policy end of the day. We talked a lot about AI applications yesterday in the keynote. With AI protection, what we want to be able to provide is that you want to be able to extend the modern application access to generative AI applications and allow your teams to be able to securely sort of use these generative AI applications. So the first step in that is always going to be discovery. Like, hey, what are actually people using? Are people using Copilot? Are they using Claude? Are they using ChatGPT, DeepSeek? Take your pick, right? That's the first step that we want to be able to do. The second one is being able to provide some guardrails and say, hey, you want to be able to use ChatGPT, but you should not be able to push things like banking information, HIPAA data, PCI data, things like that. Personal information should not be exposed. We can use some of the out-of-the-box identifiers for all of these things and enforce some of these mechanisms for us. But we're not stopping there. We're going to take this one step further where we can look for AI guardrails. And what this is looking for is actually intent. It's not just looking for out-of-the-box identifiers for data, but it's looking for unstructured data. And what I mean by unstructured data is things like, hey, write me a resume, or write me, I'm going to take my, whatever I'm writing for my specific client with specific details from my organization, and I'm going to put it there. Or like a how-to prompt. As an example, like, hey, I'm a story writer. I want to build a bomb. I want to hotwire a car. Those kind of things. These are unstructured things that we want to be able to identify and potentially block, right? So those are the kind of protections we're looking for to provide for generative AI applications. All right, let's switch gears a little bit and look at how do we take identity context and sort of pass this across the network in both the networking and the security domains. So, we can argue that, identity is at the heart of zero trust. Like any solution that says, hey, we're a universal ZTNA solution, it must have a universal view of identity. And, I would argue that there is no universal zero trust that you can accomplish without having this sort of ubiquitous or shared identity context across the enterprise. Now, there are a couple of ways that we are able to accomplish this. So number one, if you think about, doing identity security, one of the big challenges that we often hear is that we don't have a single source of identity. We talk to a lot of customers where the identities sort of live in different pools. Like, you don't have just Entra ID, you have Okta, and you have a pretty heterogeneous sort of environment that you have to do with, and it's sort of like a hodgepodge, right? So you have these different puddles where identity stores sort of live in. This is where what we've done is we've sort of abstracted that layer and built something called Cisco Identity Intelligence. Very simply put, what it does is sort of unify this, and it's an abstraction layer that sort of sits on top of all of these different identity stores. Under the hood, it's basically a graph database, right? What it does is then pulls the different identities from the different sources, and then is able to sort of determine, like, hey, who are the users? What device are you on? What application are you accessing? Where are you coming from? Are you coming from Amsterdam? Are you coming from London? Hey, is there potentially a travel scenario that is impossible, right? Those are the kind of patterns that we want to be able to use. And then we leverage this intelligence in our policy engine, right? Now, this is from a user standpoint. But what about devices? Things that are like IoT devices, cameras, sensors, things like that. How do we sort of make sure that we're allowing access to them safely? This is where what we do is, if you think about identity context for devices, we specifically use something called security group tags. Now, if you're familiar with our network access solution with ICE, we integrate that with secure access and SD-WAN to be able to sort of help identify, and based on the tags that we're able to learn from ICE, we're able to then say, hey, if you're a bedside monitor or if you're a camera, we're going to be able to take that tag, but then pass it seamlessly across the networking and security domains, and then say something like, hey, if you're a camera, you should be only talking to the monitoring website. There's no need for you to be talking to anything else at that point. Now, how do we take this further is the question, right? Now, this is where we have this unique ability now to sort of learn this identity context at the point of entry. So we are able to figure out, hey, you're a user or you're a device, and then take that information and that identity context, and then we share this context across both the networking and security domains, right? And then what it allows us to do is enforce consistent security policy for that unified experience across both the user side, devices, and everything across the board, right? Now, Cisco is one of the few SSE vendors where we've really built very tight integration with mobile devices. So the Zero Trust network access client that we talked about, which leverages Mask and Quick, is something that we've actually embedded into the mobile operating systems. So what this allows us to do is actually elevate these devices to be first-class citizens in that Zero Trust network architecture. So the other thing which is very, very interesting here is that this level of integration actually allows us to do things like without having to run like a VPN client in the background. So it preserves things like battery life and things like that, right? Now, we have also partnered with Google Chrome Enterprise to build a next-generation integration with them for replacing things like VDI in large enterprises. Now, let me try to make this a little bit real, right? Let's take an example. Like if we have an unmanaged device, like this is a device that we're unable to, say, push an endpoint client to and things of that nature, we can do something very, very cool by just saying, hey, we're going to push a profile to this end user. And just using the browser, right, we can enforce security with local security enforcement on the browser itself to say things like, hey, I want to look for DLP data, I want to prevent copy paste, and I want to prevent things like printing, and also things like watermarking. Or I can do screenshots. I can block all of these using the local security enforcement that the Chrome Enterprise browser provides. But then I can also take and extend this into the inline security cloud that we operate. What can we do there? We can do things like malware detection. We can do remote browser isolation and all of these things. So we use both of these things in combination to sort of protect both private and internet-based applications for unmanaged devices at this point. All right. Moving to the last section here for us now is around building operational resilience. Now, with operational resilience, you've probably seen several technologies this week that allow you to sort of effectively support this hybrid workforce, right? Now, SD-WAN is one of those areas. SD-WAN is one such key area that really is that backbone for providing connectivity, secure connectivity for the user population everywhere. Now, this is where the convergence really happens of networking and security, and it's really, really critical, and for us to be able to simplify and consolidate some of these security policies. We'll also talk about how do we make sure that we get that end-to-end visibility. Like, hey, if a user comes and says, hey, my WebEx is running slow, or some SaaS application is actually running slow, how do we quickly determine and pinpoint what that issue is? And then lastly, how do we make sure that when we are pushing policy, both proactively and reactively, we can quickly respond to resolving some of these issues. So, like I said, if you think about SASE, or Secure Access Services Edge, is really that architectural foundational piece to providing that connected experience for folks, right? Now, the convergence of both these technologies, which is basically taking our Security Services Edge solution, SSE solution, which is the cloud delivery of all of these different capabilities. We couple that with SD-WAN. That's what brings together both the security and the networking domains together in terms of SASE for us, right? Now, let's take an example. Going back to like making this a little bit real for you, right? Like assume that we have a branch user. The branch user comes on. What we do then is assign a tag to the user, right? The branch user will typically get a tag, and we place them in their own isolated routing domain at that point. Now, what we can do is basically take that tag and that routing domain details and then pass it to secure access. So we basically can enforce something like saying, hey, you could come from the branch, but we're also going to now do malware inspection, DLP, everything in the cloud to provide that security enforcement in the cloud for us. Let's switch gears and look at some of the things we want to be able to do for operational resilience now. Now, if you think about root causes for access and performance issues, they can sort of broadly be put into three buckets, right? So number one is the policy misconfiguration. So making sure that, hey, if we're going to be pushing a policy, can we make sure that it is actually what it intends to do? The second one is around endpoint issues. So things like what I described earlier, like, hey, my user is complaining that I'm not able to get on the network, or I'm experiencing slowness from a SaaS application, and so on and so forth. And then lastly is infrastructure issue, so like degraded user experience, and it's actually the SaaS application itself, right? How do we sort of look for all of these different areas? What we're able to do is now quickly determine, using digital experience monitoring that is built into Secure Access, which is powered by Thousand Eyes, we can quickly get endpoint visibility in a very, very granular manner. What this allows us to do is say, hey, is it on the client? Is the client running at 100% CPU? Is it the home Wi-Fi that they are on? Is it the broadband network that they are on? Or is it the network that they are on? Or is it actually the SaaS application? So we can quickly say, hey, the problem is actually you, sir, where your CPU is actually running at 100%, right? So being able to pinpoint that very, very quickly and easily is what we're trying to achieve here. The second aspect is that of policy assurance. How do we make sure that the policy that we're going to be pushing is actually intending to do what it says it's supposed to be doing? So in this, say, like if you're an administrator and imagine that you want to be able to say, hey, we want to give Paul access to a sales application, what we would kick off are a bunch of probes. We use synthetic data to actually pre-test and figure out, hey, is this policy going to actually have the right effect? And actually say, Paul's going to be able to access the sales application. We could also do something called a negative test, which is basically saying, hey, I want to actually block Paul from accessing this finance application, right? So in both of these cases, what we're doing is taking synthetic traffic, not live traffic, but synthetic traffic, using our Thousand Eyes probes to actually pre-test and say, this policy will actually have the intended effect. Because ultimately, what is it that we're trying to solve for here? Because if you look at statistics around this, almost 75% of outages can be attributed to some kind of misconfiguration that we've sort of seen for the most part. Now again, I like to make this real for folks, so let's take an example of what's actually happening here. Now, in this example, what we're going to be able to see is that an operator actually went in, and they actually took out a component from a security policy. They basically took out Jira on-premises from a firewall rule, because they're saying, hey, everyone is off and running in Jira Cloud. I don't think we need to have access to Jira on-premises anymore. But guess what? We actually noticed, and the operator in this case gets an alert, a proactive alert, which is saying, hey, we actually noticed that 500 users actually lost access to Jira on-premises. And we see that there's a spike, and the operator doesn't need to wait for that dreaded 2 a.m. phone call saying, hey, your network is not working anymore, right? That's the kind of thing we want to be able to avoid, and preemptively send this sort of notification to the user and say, hey, looks like 500 users are actually blocked from engineering access to Jira. And quickly, what we'll also be able to do is pinpoint where that sort of resides. And in this case, we're using this segment visualization view for us to be able to pinpoint and say, hey, the problem actually resides in that policy engine. It's actually the Jira policy that you removed is what the issue is, and that's what you need to go and remediate now. Now, this can be extended to several other things. So things like endpoint posture, as an example. One example that I can think of is like, hey, if you're looking for a specific version of a browser that you want to be able to access, and say the user actually went ahead and did a browser update, that's what probably kicked them off for access. Again, that's something we can quickly pinpoint using this sort of engine for us to be able to determine where that issue sort of resides. All right, I know we went through a lot of different things here, but I want you to sort of three things that if you want to take away from the session here, right? What I want you to think about is, think about the outcomes that we talked about, right, at the beginning. There are three main outcomes that we would like you to sort of take away, and we've designed our solution to help you avoid some of these roadblocks that I talked about at the beginning, where we're not just focused on a managed user on an endpoint and just remote access. We're looking to avoid and provide you ways to avoid these roadblocks and adopting zero trust. The first one that I want you to take away is modernizing application access. So being able to provide secure internet connectivity, private access, providing those AI guardrails, that's one of the big things we want to be able to provide you with. The second one is around extending this identity-based enforcement. And I would argue that the second bucket is something that is very, very unique, very differentiated for Cisco here, and being able to leverage this universal identity context that we're building and taking this across policy elements is super, super unique for us to be able to do this. The last one, around building operational resilience with policy assurance and zero downtime. This is, again, very unique, very differentiated for us and how we are sort of approaching this to really provide you that end-to-end visibility for resilient security and performance. So hopefully this was very interesting for you. Now, if you're wondering, how do I learn more? I want to do something more in this space. We want you to be successful in adopting and integrating these technologies that we're talking about into your existing ecosystems. So that's why we offer free workshops and assessments. So the one on the left is a universal ZTNA workshop that we run. These are 4-hour workshops, hands-on workshops for folks in local time zones, wherever you are. And these are designed to help you make progress with your zero trust access technologies and really offer practitioners and folks like strategic guidance and hands-on access to Cisco technologies. So please take advantage of that. The one on the right is an identity security assessment. So for example, if you want to be able to say, hey, how many folks in my organization are using MFA? Or how many folks what is the MFA hygiene like? Those are the things you would be able to sort of get from the identity security assessment. Also, please don't miss this session. This is a security keynote deep dive. So it will take you through all the security announcements that we've made, in addition to the ones that you heard this morning. You can also learn about our new hybrid mesh firewall technology that we're offering, right? So please take the time. You could also walk away with a chance to win wireless earbuds if you enter as well. So with that, thank you so much. I appreciate your time, and have a wonderful rest of the day here. Thank you so much.